Good afternoon, dear students. How are you? I'm good. Yesterday, we learned thermodynamic processes, isothermal, isobaric, isochoric process, cyclic process, and adiabatic process. So then we learned what are the mathematical terms to use: isothermal, adiabatic, isobaric, isochoric, and cyclic process. So we can review that quickly. Adiabatic process. For adiabatic process, what is the condition for the adiabatic process? Q is equal to 0. That means there is no heat transformation, no exchange of heat in the thermodynamic system or any system. There is no flow of heat from system to surrounding and surrounding to system. This is the condition for adiabatic process. And what is the next condition for the what is the condition for isothermal process? Isothermal. So what is constant here? T. Temperature is constant. So we have to write difference in temperature is equal to 0. It is equal to 0. That means throughout the process, temperature is always 0. There is difference in temperature is always 0. That means temperature is constant in thermodynamic process. Then what is the next one? Isobaric. What is the condition for isobaric process? For isobaric process, pressure is constant. So there is difference in pressure is always 0. Okay, so if the reaction contains the difference in pressure is equal to 0, then that reaction is known as isobaric reaction. So you can write pressure constant pressure. So in adiabatic process, condition for the reaction Q is equal to 0. Isothermal process, dt is equal to 0. Isobaric, dP is equal to 0 means P always constant throughout the process. Okay, from the initial to the final stage, pressure always constant. Then what is the next one? Isochoric process. So in isochoric process, which one is we consider that constant? Which one is constant in isochoric process? Volume is constant. So how to write? Difference in volume is equal to 0. Difference in volume is equal to 0. That means there is no change from initial to the final stage of the reaction. Volume is not it's not in the there is no difference in initial to the final stage of the reaction. So difference in volume is equal to 0 throughout the reaction. So volume of particular reaction is constant. That reaction is known as isochoric process. Then last one, cyclic process. You know that cyclic process means a system returned to the original state after completing many steps, and it's completing many steps with many changes, but it's written into the same stage of the initial stage. Okay, so it is written into the initial stage after completing many changes. So what is the condition? What are the condition we have? There is difference in internal energy, du. Difference in internal energy is equal to 0 because there is no change from in the cyclic process. Then what is the next one? dH. There is no change in enthalpy. So dH is equal to 0. Then what is the next one? dP. No change in pressure. So pressure also it is constant. So dP is equal to 0. Then what is the next condition? dV is equal to 0. dV is equal to 0 means volume also it is constant throughout this in the final and the initial stage of the cyclic process. Okay, so dV is equal to 0. Then dt means temperature, difference in temperature, also it is 0. Okay, so this is the review of yesterday's topic. So you have to study this process with the condition. You can study this with this table. Okay, then we can move into the move in today's topic, functions of thermodynamics. So we already learned that what are the processes involved in thermodynamics, what is system surrounding, and what are the types of system with the basics of chemical properties and physical properties, and another classification of system with them depending upon the nature of the boundary. So extensive property, intensive properties. So we learned these all things, and the final of this thermodynamics, we have functions. Okay, so totally we have two types of functions in thermodynamics. They are functions. They are two. We have two functions. What are they? State function. Next one is Bath function. State function and Bath function. Generally, these two functions are thermodynamic function property of a system. But this both thermodynamic property of a system, how it is differing from the state to bath, how it is differing. For understanding this difference between bath function with the state function, we can take one reaction, reactants, produce products. Okay, so reactant produce product. Throughout this reaction, so the variables we used in this one thermodynamic reaction: pressure, volume, temperature, internal energy, and enthalpy. Okay, and number of moles. So these are the variables, these are the examples of variable we used in the thermodynamic process. Pressure means the pressure what we applied from throughout initial to final stage, that is pressure. And volume, you know that, temperature, you know that, and the internal energy is also the energy of the molecules which is present in reactant and product. Then enthalpy, it is heat energy, and N is number of moles is present in this reactant and products. These are the variables are involved in one thermodynamics reaction. Then consider that to measuring this pressure, volume and temperature from reactant to the product, then you can realize that throughout the process, pressure is not depend upon the path of the reaction. That means when you change, when some reactants are reacting together and they produce the product, this is one thermodynamic reaction. Okay, then during that process, pressure is applied on that reaction. In that system we apply some pressure, and that system contains some volume and temperature. We apply some temperature and pressure into that thermodynamic process. Okay, now you can see the pressure and temperature, volume, these all the variables are involved in this thermodynamics reaction. It's not depending upon the reactant which is converting into the product. That means the path which they travel, the reactants which they traveled into the path to convert this in the products, it's not depend upon that pressure, volume and temperature. These are the variables are not depend upon or not depending the path of the conversion of reactant into product. Okay, so the conversion of reactant into product, that path is not the pressure and volume, temperature, these are the variables are not depending upon that path. Okay, so this type of variables like pressure, volume and temperature, then internal energy, these are the variables are not depending upon the path of that full reaction. Okay, so this type of variables generally known as they are state function. So what are state function? The variables which are used in the thermodynamic process, they are not depend upon the path of that thermodynamics reaction. They are not depend upon the path of thermodynamics reaction. So that type of variables are known as they are state function. So what you know that the state function, what are the state function? We know pressure, volume, temperature, internal energy and enthalpy. Okay, so these are the variables are the example for state function. So what is state function? Variables are not depend on the path. That means the full reaction. So where it is traveled, the reactant which is traveled from initial state to the final state, that route we know that is path. Okay, or we can call that is manner. Okay, so these variables are not depend upon that path or manner or that route. Okay, so this is important. State function means does not depend on the path or manner. So what is state function? State function is a thermodynamic property of system and their specific value or does not depend upon the path or manner of the particular state which is reached. That means the path and manner of that particular thermodynamics reaction. This is state function. And path function means it is opposite. State function opposite to path function. Here state function, it's not depend upon the path. Then path function means what? It's the variables which are used in the thermodynamics reaction, they are depend upon the path of that reaction. So that is path function. What is path function? Path function is also a property of system. We know that this is thermodynamic property of system. Both the function are thermodynamic property of system. So path function also, it is a thermodynamic property of system, and the value of the variables which are used in this reaction, it's not it is depend on the path of the system. Okay, so it's depend on the, you have to write it's depend on the path or manner. So what is path function? Depend on the path. The variables are depend on the path. It is path function. The variables which are does not depend on the path, they are state function. Which is depend on the path, it is path function. Okay. So what are the example for this one? This path function: work, heat. You know that we denote here work means W, heat, how to denote heat? Q. Don't forget this Q. Work means W and heat means Q. Here we have one difference in work. When work is happen in the reversible process, it is different from the irreversible process. So both the reversible and irreversible process, we will get the work values is different. So functions are completed. Next, variables of thermodynamic. One of the most important variable, internal energy. Internal energy is denoting here as U, capital U. What is internal energy? When you take one atom or any molecule, they have some energy in within that atom and molecule. So that energy in the internal of the atom and the molecule, we have some energy, they contain some energy. So that energy is known as internal energy. And how to measure that internal energy, how to write the formula for this internal energy. Generally denoting internal energy as capital U, it is internal energy. Internal energy is a characteristic property of a system. So it is a characteristic property, that means one of the physical property of a system. Okay, it's not a chemical property, it is a physical property of a system. Then how to measure or how to find out the internal energy of a system? To finding out the internal energy of the system, always it is equal. Okay, so the internal energy of the system, it is equal with the energy of all the molecules, ions, atom which is present in the particular system is internal energy of a system. Okay, so in one system we took some amount of gas or some amount of liquid or any solution. Then you can, if you are calculating the value of the internal energy for a system, then you have to consider the internal energy of each ion molecules and the constituent, what are the constituents are participating in that system. The total of that that internal energy of all the ions, molecules and the constituent of the system is known as, it is equal with the internal energy of the total system. So we have to write internal energy of a system, U is equal to, why we put U? U is denoting internal energy, capital U. It is equal with internal energy of the translation energy. So first, translation energy. Translation energy. So what is translation energy? Translation energy means exchange, transferring one energy into the another energy. Okay, so transferring or flow of heat is translation energy. And next energy, vibration energy or vibrational energy. Vibrational energy means what? So all the molecules or the atom, when they get the heat from the source, then it will get vibrating. Okay, they will get some vibration. So that energy also we considering in the internal energy. So the energy we used to getting the vibration energy. So the vibrational energy also participating the internal energy of the system. Okay, the next one, bond energy. Okay, bond energy. So energy which is used in the bond, that bond energy, the energy of that bond also considering under the internal energy, it is bond energy. And next energy is electronic energy. Electronic energy, it is present in the particles of that atom or molecules, that is electronic energy. And next energy, the molecular interaction energy. Molecular interaction energy. Molecular interaction energy means, one molecule combine with another molecule. Okay, so this type of energy molecule is interacting with another molecule, so that is molecular interaction energy. So the energy which are participating or participating in the internal energy, they are translation energy, vibrational and bond energy, electronic energy and molecular interaction. Okay, so how to write the formula for the internal energy? If you write the translation energy, then you write here UT. Translation is denote UT. Translation energy. It is internal energy, so UT. Then vibrational energy, you have to write UV. V is denoting vibrational energy. And what is the next one? Rotational energy. So the atom or the in atom we have electrons. So the atom constitutes some electrons. So electrons are rotating or spinning. Okay, they are in spin and anti-spin. So that the energy which is used to spinning the electron in an atom, it is also considering under this internal energy. It is rotational energy. So we denote here rotational energy is UR. R is rotational energy. Then how to write bond energy? UB. Bond energy. B. Okay, capital U and B. Then what is electronic energy? Capital U, E, small e. This is electronic energy. Then molecular interaction energy, it is interaction. So capital U, I, interaction energy. From these all the energy, for the totalizing or sum of this all the energy is internal energy of the system. Then writing the internal energy of the system, U is equal to UT plus UV plus UR plus UB plus UE plus UI. UT, UV means vibrational energy. Then UR rotational energy, UV bond energy, UE electronic energy, and UI molecular interaction energy. So internal energy of a system is equal to the energy which is possessed by all the constituent. It is all the constituent of the system. That means the atoms or ions or molecules, anything it's in the system, that all the energy it is participating, the total of that all energy is internal energy. Or simply we can say the total energy of all the molecules which is present in a system is called internal energy of the system. So energy of the system in thermodynamics is only considering with internal energy, not with the value of all other absolute energy, but it is considered, the energy of the system is considered with the internal energy. Then we have some importance of internal energy. Internal energy is participating the physical structure differences. So the physical structure differences means the allotropes. We can consider the allotropes of carbon. So what are the allotropes of carbon? What are they? Graphite, diamond, and fullerenes. Okay, so these all are the allotrope of carbon. What is allotrope? The constituent or the atom which is present in that compound is same, but their structure and the interaction with the molecules or atom are different. They are allotropes. You can take the example for allotropes. Allotropes of carbon. Graphite. Take example, graphite. Graphite daily we are using in a pencil. Here you have one black color one in the center of that pencil, which is carbon compound, but they present in different structure and the bonding also different in the graphite. So the name of this carbon is graphite. Okay, and then you can take a diamond. I hope you all know diamond. So diamond is a white color compound. It's a precious one, and you can differ this graphite carbon with the diamond. This is black color one, but that is not similar with this graphite. Okay, so these all are the carbon compound, but their structural and bonding is totally different. They are totally different, but they are the compound of carbon. Okay, they are carbon compound, graphite and diamond. So how we differ this one with this structure, how they are differing the same carbon compound with the structure because of this internal energy. So the internal energy of graphite is different from the internal energy of diamond. Because of this difference in the internal energy, they can show the differentiation in the structure of graphite and diamond. This is important of internal energy. This is the importance of internal energy of many systems. So internal energy have some characters. First character, it is one of the extensive property. It is extensive property. It is extensive property means it is depend upon the mass of that system. Okay, so internal energy is depend upon the mass of the system. So the internal energy is depending upon the amount of the system means when you double that amount or triple that amount, then the internal energy of the system also will double and triple. Okay, because we are increasing the amount of that system, then also it is increasing the internal energy. So the amount of system also increasing, then if along with the amount increasing, the internal energy also it is increasing. Why? Because of the extensive property. Extensive property means the extensive properties always depend upon the mass and size of a system. So here it is depend upon the size, mass of the system. Then the next character, it is a state function. The property wise it is extensive property, but state function, bath function, from that function of thermodynamics, it is state function. So state function means what? It's not depend upon the path of that system. Okay. So the variables which are used in the system, temperature, pressure, volume and number of moles, from that variables which are not depending upon the path of that system. This is second character. And third character is change in internal energy. Difference means we have to denote D. Change means delta. Okay, delta U means what? It is change. Change in internal energy. Change in internal energy is denoting here as delta U. How to find out delta U? So the changes which is happening in the internal energy, to measure that, to subtract internal energy of final stage, subtract with internal energy of initial stage. So the internal energy of initial is subtract with the internal energy of final stage. When you measure the internal energy from the reactant to product, we have to consider the internal energy. We have to denote the internal energy of internal energy of initial state and internal energy of final state. Then we can easily measure that the change which has happened in this both the stage of the internal energy is change in internal energy equal to UF minus UI. That means internal energy of final minus internal energy of initial. Next character. If you calculating the internal energy of cyclic process, what is cyclic process? From the compound will, the system will return into the initial state which completing all the changes, cycle of changes. So that that reaction is known as cyclic process. When you calculating the internal energy of cyclic process, you will get the same reaction at the end of the cyclic process. So there is no change in the internal energy of initial to the final stage of the cyclic process. That's why if you calculating the internal energy of cyclic process, then the internal energy of cyclic process should be 0 because there is no changes. And we have two conditions: negative internal energy and positive internal energy. How to get the negative internal energy? If the initial stage of the internal energy in one reaction, initial stage of the internal energy is greater than the final stage of the internal energy, then the change in internal energy of the system is, if the system contain the condition initial stage of the internal energy is greater than the final stage of internal energy, then if you subtract this initial stage with the final stage, then you will get negative internal energy of the system. Okay, so what is the condition for to getting the negative internal energy? Initial stage of the internal energy greater than the final stage of internal energy, and it is opposite for the positive internal energy. How to write the positive internal energy? What is the condition? If the internal energy of the final stage is greater than the internal energy of the initial stage, then the changes in the internal energy delta U is equal to UF minus UI. It will produce only positive internal energy. Okay, so this is greater, this is lesser. So if you subtract this, then you will get the positive one. This is greater, initial is greater, but here it is lesser one. So you will get definitely it is negative value of the internal energy. So greater internal energy of the initial stage will produce the negative change in internal energy, and greater final internal energy of the reaction will produce delta U is equal to positive. So these all are the characters of internal energy. Take page number 190 and write here what is state function. Mark from here, a state function of a thermodynamic property is written up to here. Any example, any two example, pressure and volume. Mark this two. Then what is bath function? Full with two examples. Then what is internal energy? Internal energy, write like this: internal energy is denoted by symbol capital U. Then the internal energy of the system up to here. Then write here, this is for 2 mark. If they ask 3 mark, then you have to write this also. Okay, then write the importance of internal energy full, characters of internal energy fully. From the initial to the final equation uf is equal to up to here. Okay, okay, study well. Thank you, students.